All right, 1-3, solving equations with variables on both sides. This is actually a big part of algebra, is you're going to have variables on either side of the equation, and that is no bueno for solving it. It's not good in solving an equation. So what we need to do is we need to get all of the variables to one side. This needs to go. It's just a moment. So, hopefully it doesn't. All right, so here's the thing. When we have variables on both sides of the equation, some funky things start to happen. All right, first thing is we could get a solution to the equation. That just means we get something like, for example, in A, K equals, I don't know, 4. You could get K equals 4 in the first one. All right, that could be an answer. But you could also get two other, so to say, possible answers to your equation. Now, what can happen is when I get all the variables to one side, they go away. Okay, Katie, they all go away. They disappear. When that happens, you're going to get one of two answers. Either one, it's going to be no solution. You're going to get something that's false, like 15 equals 20. And you and I both know 15 does not equal 20. So that would be no solution. Or, Grace, we could get something that's like 7 equals 7. And that would be infinite solutions. Okay? So at this point, now we kind of open up Pandora's box, so to say, and we can get one of 3 different scenarios. The first scenario, which we're going to focus on today, is when we get a solution. Okay, we just have to get all the variables to one side, and we're going to end up with a solution. And like part 2 of this lesson is what happens when all the variables go away. And that's the other part. And that is when we get no solution or infinite solution. Okay, so some equations have variables on both sides. To solve these equations, you can collect the variable terms on one side of the equation and constant terms on the others. So how do we do this? Well, we do it through adding or subtracting variables. And you'll see what I mean by that. Okay? Chucky, are you good? Can I move on?
Yeah.
All right, so now we have these 3 problems. I'm going to try and get them all on my screen for everybody here. Okay, so I have these 3 examples. I'm going to walk through these 3. Notice in A, I have K's on the left and on the right, and I need to collect them and get them all to one side. Now, this is not in any notes anywhere, so you got to pay attention. I like to move my smaller variables. And Mrs. Simonian is asking me, Harmon, what do you mean by smaller variables? And I mean, well, if I look at 3K and 8K, which one's smaller, Mrs. Simonian? 3K. So what I'm going to do here is I'm going to think to myself, I'm going to be like, how do I get rid of a positive 3K? And I'm going to go ahead and subtract it. Notice, and this is very, very important. Notice, I line up my K's. I kind of put them underneath each other. So on the left side, I have 45. On the right side, I have 8K minus 3K. That's 5K plus 25. Yeah. So now I have all my K's to one side, and this is a 2-step equation. So what I'm going to do here is I'm going to go ahead and move my constant to the other side by subtracting 25. And I have 20 equals 5K. And if I ask Tyler, Tyler, you there?
Yeah.
Tyler, how do you get rid of times 5?
Wait, what? Divide by 5.
Divide by 5. All right, I might help you, be able to help you out. So we divide by 5 and we get 4 equals K. Oh, look at that. Mr. Harmon said that at the start of class. Gotta take that long round. All right, try not to lose these. We're getting all of them. No. Right. Clean the pencil. Clean the pencil. Yeah, see? All right, now for B, Nate, I know you just came back from the bathroom, but I'm going to ask you this because this is kind of a real quick review. Now we're going to have variables on both sides of our equations, okay? We have them on the left and on the right. And we want to get them all to one side. And I said my biggest hint was you're going to move the smaller of the two, okay? I have negative 5z and I have positive 5z. Which one of these is smaller? Negative 5 or positive? Negative 5. Negative 5. Very good. So now what I'm going to do is in order to get rid of negative 5z, I'm going to add 5z. Now this is 7 equals 17 plus 10z. All right, and now I have this positive 17. Julie, how do you get rid of positive 17?
Minus 17?
Yeah. So we're going to go ahead and subtract that 17. Those cancel. I'm left with 10z on the right. 7 minus 17, you might need a calculator for that. But Harmon is a human calculator, so it's negative 10. Now, Ellie, how do you get rid of positive 10? Ellie, how do you get rid of that times 10?
Okay, so what I did was I divided them.
Ooh, perfect. You divide by 10, you get negative 1 equals z. All right, and now for a question like C, C is weird. Okay, so I'm going to zoom in on C. Now, why is C weird? Well, C is weird because it kind of bucks the system here. Okay, it goes against the grain in the sense that I have negative 4x on the left and negative 9x on the right. Now, I can give you all the rules in life, but there's always going to be a situation in math where there's like kind of like an easier way to do it. Okay, Katie? There's always an easier way to do it sometimes. And you have to pay attention to it. So here, my advice was get rid of these smaller x, and we can do that. So I'm going to go ahead and follow my rules of adding 9x to both sides. Now, I'm getting some like oofs from the crowd. That's okay. All right, so on the right-hand side, I have 0. And this is where it's confusing to kids because they cancel out. A lot of kids will write nothing. Right? So we have 10. Now negative 4x plus 9x is 5x. So I have 10 plus 5x equals 0. I'm going to go ahead and subtract 10. And I get 5x equals negative 10. Divide by 5. and I get x equals -2. Now, here's the thing. This was me following my rules that I gave you. But sometimes there's other ways of looking at problems. And this is what I was kind of getting, like the groans and moans and like, for. No, but it sounds better on YouTube.
You're exaggerating.
Mrs. Simonian, what would you have done in this problem?
I actually did the problem and I added 4x to both sides.
Okay, very good. When you become comfortable with things, the only reason I gave you that kind of like hint was so you didn't have to divide by negatives. If you are comfortable dividing by negatives and remembering to flip signs and things like that, then you can certainly add 4x to both sides. Because I'm doing the same thing to the left and to the right. And here I have 10 equals -9x plus 4x is -5x. And now I divide by -5. And notice I get x equals -2. So these are two ways to do the same problem. And they are both correct ways of doing it. I'll give you a second to soak all of that in, Nate. Okay. I'm kind of curious about what might. You go to Myrtle Beach often? Do you like it there? What's your favorite thing to do there? Do you like boogie board, walk on the beach, collect seashells, like boardwalk?
I go with my friends.
Oh, that's cool. Myrtle Beach is a fun place. All right, now let's look at D. D is a little bit more difficult. And there isn't a smaller x. There isn't a larger x. There's only, in the words of Ivan Drago, pain and misery. Oh, you can just throw it out. I don't really care where you were.
I knew he was looking something.
You were at the nurse?
Yeah.
Cool. All right. Now, let's, no, that's not what you said. You said number 10.
See how I remember that?
You didn't even,
Can I get a new seat sometime?
probably later on this year, maybe second month.
All right.
All right, now D. Now we have these parentheses. What do I do with parentheses? Mike. Yeah, we do parentheses first. But what do I do with that number outside? 3 times 3. Do you remember what that's called? Starts with D, ends in distribute. Distribute. 3 times 3 is 9, so I got 9x. 3 times -4 is -12. Equals. What do you think I'm going to do with that 1/4, Mike? I'm going to make it a decimal, and then I'm going to go ahead and distribute. So I do 1/4 times 32, and I told you I'm a human calculator. So I do 1 times 32. That's 32 divided by 4 is 8. Here, 1/4 times 56. 1 times 56 is 56. Divided by 4 is, you know? You do not.
Wait. I can try to find out.
14.
I was going to say that.
I know you. Okay, thanks for allowing me to answer. So I have 9x minus 12 equals 8x plus 14. Now, notice I have nothing funky like the last problem. So what I can do is I can go ahead and move that 8x And that's going to be x minus 12 equals 14. Now, some people will write a 1 in front of there. Sometimes I do, sometimes I don't. I tend not to, because when I only have one of something, I just write that variable, because it just is understood that there is a 1 out in front. And now I'm going to go ahead and I'm going to add 12. And this is going to give me my answer of 26. Now, as I said, not in every case are we going to have a single solution. This is kind of like part 2 of the lesson. So the first part, we always had like x equals a number, y equals a number, k equals a number, m equals a number. Now, I might not have a solution. Everything might go away. I might have no solution. I might have one solution, might have infinite solutions. The way you'll tell if it's one or the other is if you get x equals a number, that's one solution. You're going to actually tell me what it is. You're going to say x equals 3. If you get a true statement, like 15 equals 15, you're going to write infinite solution. And if you get something like, I don't know, 15 equals 12, that's going to be no solution. So you could have one solution. This is what it looks like. Okay, we're not going to write one solution. We're just going to say x equals 3. That's what it looks like. Infinite solution. It's going to look something like, we could have like x plus 12 equals 12 plus x. Notice both sides have a x and both sides have a 12. They're both positive. We're good to go. If you don't see it there, well, you can go ahead and you can say, all right, let me get all the x's to one side and subtract x. And then you get 12 equals 12. And that's a true statement. That's infinite solution. Now, no solution will look something like this. X plus 5 equals x plus 3. Notice both sides have an x. One side has 5 and one side has 3. Notice it's not the same thing on both sides. If you don't see it there, that's okay. You can always go ahead and solve it and start subtracting your x's. They cancel. And then notice you get 5 equals 3. And this is false. It's not true. So let's go through some problems here. All right, and there's going to be different times in which people see it at different moments. As soon as you see that it's infinite solution or no solution, you can write that. Okay, I'm going to write it. So, for example, number 8, I'm going to go ahead and distribute that 9. I'm going to start to solve this. I have 9z plus 12 equals 9 times z is 9z plus 9 times 3, that's 27. Now, for me, I notice this is going to be no solution right here. Why? Well, I both have 9z on both sides, right? I can't add 12 something to something and add 27 to the same thing and get the same number. It doesn't work like that. Okay? Now, if I don't see it, I'm going to keep going. I'm going to say, let me take away that 9z. Let me get all my z's to this side over here. They cancel. I'm left with 12 equals 27. At this point, I would say that's not true. It's no solution. All right. So at whatever point, Mike, you see that it is no solution, you can write it there. Mind you, on any type of task, if you're showing work, right, it's going to be better for you than not showing work. Okay, so if you just wrote no solution at the top and you got it right, good for you. If you wrote infinite solution at the top and didn't show any work, well, then you'd be wrong and you would lose all of your points. You got to show some work at times. Number 9. Okay, I'm going to go ahead and try and solve this. I'm going to get all my variables to one side. So I noticed I have a 7W and an 8W, so I'm going to go ahead and subtract 7W because that's smaller than 8. So I get 1 equals W plus 1. All right. Let me subtract 1, and I get W equals 0. And here's the funny thing. Mrs. Simonian will vouch for me. Most kids will see that and say no solution, right? They'll make up. W equals 0, no solution. They just write no solution. That's not the case. 0 is a number. Don't hate on 0. It's a beautiful number. Love 0. Love to multiply by it, love to divide it, add it, subtract it, great number. Okay? So when we have this, don't say no solution. There's definitely a solution. It's 0. Okay? Now, last but not least, here, I'm going to go ahead and distribute that 3. That's going to give me 6a plus 6. Over here, can distribute that 2. And that's going to equal 6a plus 6. Now, at this point, Kitty's probably like, Harmon, I see it. I see it. Infinite solution. It's the same exact thing. I'm good. I don't need to go any further. I'm going to say, awesome, Katie. But Chucky at home might be like, I don't believe you, Harmon. And I got to keep going. So Chucky would go ahead and subtract that 6a from both sides. And he would say 6 equals 6. And then he'd be like, all right, I believe you now. And he would write infinite solutions. Now, here's one thing I want you to notice. When it was no solution, I wrote no solution. When it was infinite solution, I wrote infinite solution. What did I not write? I didn't write one solution. I never write one solution. If there is a solution, I find it. Okay? I should not see on your papers one solution. All right? There is a solution. I want to see it. I want to know what it is. All right, you guys got 3 problems right here.
Well, there's actually 5.
I only got 10 minutes. So we got 3 problems right here. I need you guys to work through those. I wouldn't say it's like cold. It's just like a chill. I think I want to heat.
I don't think you did. Here it comes. Yeah.
No, it's colder. Definitely colder. Number 3. Okay, so negative 4p plus 4p is 0. So they would cancel out. So you're going to get like 4 equals 4. Okay? Another minute or two.
Found a new electrician,
You did.
master electrician, who used to work for WSSB.
Cool.
Really is. Services.
The other one.
He is really hard. Yeah, we're getting our basement. It all done up.
Okay.
Yeah, 2 times. Room up. Not, it didn't go in, but.
All right, let's go ahead with number 1 now. Mr. Harmon's about doing things easier and not harder. So we're going to do this Mrs. Simonian's way, which I'm going to subtract 3x. Why? Because it's going to allow me to get my variables to one side quicker. So I divide by -5, and x equals -2. So there's my one solution. All right. And to be honest with you, this is just me talking off the top of my head, kind of thinking, right? They should probably get a 1 solution, no solution, infinite solution, things like that. I'm kind of thinking about it, right? Okay. So let's see what happens here. I'm going to distribute that 1/2. Okay. I have 1/2 of 6, that's 3h. I have 1/2 of 4, that's -2. -5h plus 1. Okay, I'm noticing, ready, Nate? Watch this. 3 h's, 5 h's. They're different, aren't they?
They are.
They are. So guess what? I'm thinking I'm going to get another 1 solution type of deal because I have different variables on each side. But I'm still thinking at some point I'm going to have probably one of each of these. Making sense? So now I'm going to add 2. Oh boy, it's getting weird here. It's getting weird. 8h equals 3. Divide by 8. H equals 3/8. It's almost as weird as showing up 20 minutes late to class.
Oops. Although it's Nate's friend. His friend got stopped on here.
Shh.
What?
Hey,
Oh, no,
hey.
that's
Mike.
Gosh.
Mike. Shh. Here we go. Last one. Look. Distribute that 4. And this one's tricky. It says 4 minus 4p equals -4p plus 4. Now, Grace, I know this was a little tricky for you, right? Here's my advice to you. Ready? Break it down into parts. They both have a positive 4, right? And they both have a -4p, right? Infinite solutions. So when you break it down to parts, Grace, I think it's a little easier to see than as a whole. Do you see how they both have that positive 4? They both have that -4p. So you're good to go on that. All right, we're going to stop here for the day.